Okay, so we're on to step 4, where we're going to select a cable size using our IZ value, which was the current carrying capacity of the cable in the conditions it's installed in. And then based on that value, we're going to identify an installation method, what we're using in our circuits, to find the correct current carrying capacity table to go to in order to choose a size of cable which is going to be suitable for our installation. So what we're saying in simple terms is, for the lighting circuit, for example, our IZ is 7 amps. So we need to choose a cable size which is able to take 7 amps, okay? And we're also going to be checking this at the same time. This is the value we're going to fit in here, because for whatever cable we choose, let's say we go onto here and we choose a 1.5mm cable. We need to actually make sure that the tabulated value for 1.5mm, this type of cable, flat twin and earth copper cable, can actually take this amount, okay? So, and the same here, 21 amps is for the radial circuit. So let's move on to it now and have a look at it. So we've got 3 tables that I've extracted here from the on-site guide, from BS761, the large brown book, and this is table 4D5 for 70-degree thermoplastic insulated cable. And this is from BS761, 7671, the large brown book. Okay, so let's work on the left-hand side here first of all, and let's read these. So the installation method is referring to these descriptions here. So the cable could be clipped direct to a wall, could be enclosed in conduit, it could be in a stud wall with thermal insulation, okay? So all these reference methods, all these installation methods are going to have an effect on the current carrying capacity of the cable, aren't they? For example, in a stud wall with thermal insulation, this cable is going to be able to take less current than this one that's clipped direct, isn't it? Okay, and you can see here we've actually got, in this table in the on-site guide, we've got the actual values here which have been pinched from this table 4D5 and inputted here for us to make it even easier. This is the on-site guide, but it won't have every installation method, just a select few. Let's jump to this table. So this table's from BS7671, the large brown book. And this has got an extensive list of all of the installation methods. I've just extracted this page because it's relevant to what we're doing today here. But it's got every installation method that you could actually need to use in an installation. Let's go through a few here. So we've got, here's one, we've got trunking down here. Non-sheath cables in cable trunking on a wood or masonry wall. So that's the installation method. And then this last column is the reference method to go to that particular part of the table to find our current carrying capacity of our cable and select a size. So let's go through an example now for one of ours and see how it works out. So let's have a look on here first of all. We know on here, let's pick one. So let's go back and look at our installation methods on our information. So we've got the lighting circuit which is in conduit on a wall, and we've got the radial circuit which is in trunking on a wall. Okay, so let's go back in here. So I've made this easy just for this video, but look on here now. So I've got enclosed in conduit or trunking on a wall as my description of my installation method. Yep, that makes sense. And then look now, let's circle this because that's our reference method, isn't it? B. So what we're saying is if it's enclosed in conduit or trunking on a wall, we're going to use reference method B when we come to the actual table over here. Okay? And you can see above here, can't you? Installation methods for cable ratings for 70-degree thermoplastic cable. Like I said, this is from the on-site guide here. And you wouldn't actually have these values directly on the same table in BS7671. What they've done in the on-site guide, they've made it easy for us. With this particular type of cable, this commonly used cable, they've inputted the actual current carrying capacities here directly for us. But I'm going to show you this way using the BS7671 as well. So we know that we're using reference method B, don't we? And let's go down here again and just make sure we're definitely using B. So let's read this bottom one. Multi-core cable in cable trunking on a wooden or masonry wall. Right, again, it says B there. So we're happy that we're definitely using reference method B. So when we go to the table, the current carrying capacity table, we're going to go to column B, reference method B, for our type of cable. So let's fly over to this side. So we're using 70-degree thermoplastic insulated flat cable, aren't we? As you flick through the current carrying capacity cable tables, you'll see that they're for different types of cables. There's tables for SWA, there's tables for single core, and there's table here, 4D5, which is for 70-degree thermoplastic cable, which is what we're using for both the lighting circuit and the radial circuit. Right, okay, so let's put these down here so we can remember these. So for the lights, we're using, and we're in conduit, aren't we, on a wall, so we're using reference method B. And for the radial circuit, we're in trunking on a wall, And just for this video, I made it easy, so they're both B, reference method B. Perfect. Right, let's go on this side then, and let's do this lighting circuit first. So we're using flat twin and earth, aren't we? So 70-degree flat twin and earth, we know that. So let's write that, 70-degree T and E. Okay, fine. And we're using reference method B. Perfect. And what's our IZ? It's 7 amps is our IZ. Right, okay, so we need to select from column B here, don't we? Let's look at the table. We've got the conductor size on this side. Then we've got all these columns of different reference methods. 100, 101, 102, etc. A and B. This is the one we're interested in here for our 2 selections, reference method B. So let's go down here. And what I'm looking at, I'm taking this value for the lighting circuit first, this 7 amps, and I'm trying to find a cable size that's able to take 7 amps at least. So let's go down and look. So at the start of it here, 13, that's the very first one there, 13 amps. Let's go across. So we know that whatever this cable size is, when I track it across left now, it can take 13 amps. So 1 mil, okay? So 1 mil cable. So we're going to select for that circuit 1 mil cable because we're happy that it can take 13 amps. And our IZ is 7 amps, isn't it? So we've satisfied this. So we've checked our IT there. So we're happy to select a 1 mil cable because it can take 13 amps in total and we only need it to take 7 amps. So we've satisfied this equation now fully, haven't we? So let's go through this one again, this radial circuit. Again, we've got a 70-degree twin and earth thermoplastic cable. That's T and E, twin and earth, if anyone's wondering. And then we're doing reference method B again, because it's in trunking this one, same reference method. And what's our IZ? It's 21 amps. So again, we need to find a value on here, a cable size, which is able to take 21 amps. So let's go down. So 16.5, 23. Right, let's circle that. 23 amps. Let's track across here. So 2.5 mil. So what we're saying is that 2.5 mil is able to take 23 amps of current. So we're going to select a 2.5 mil cable for this one because it can take 23 amps. So let's write this in here. So again, this is fine, isn't it? Because we're saying that our cable in the conditions that it's in needs to take 21 amps. And we've selected a 2.5 mil cable because that can take 23 amps. That's the tabulated value there. So we've satisfied this equation, haven't we, again? Now let's just talk about one last thing here. With this radial circuit, you're probably thinking, hang on a sec, before you told us that we selected an A3 radial. And the A3 radial said that if we're choosing a 20 amp protected device, and we've got an assumed load of 16 amps, which is what we did right at the beginning of step 1 of this radial circuit, it was saying that we should select a 2.5 mil cable. But as opposed to just trusting what the on-site guide says and just going with that to begin with straight away, I told you, haven't I? Keep testing it, go through the whole process and make sure that 2.5 mil, we already knew this is what I'm saying, 2.5 mil based on the initial calculations, and well, not calculations, the initial tables we looked at. But we've now proven, haven't we, that if we have a 16 amp design current, which is the assumed load for a radial circuit, we're to use a 20 amp protected device. Our IZ was 21 amps, which is the current carrying capacity in the install conditions. And then we've just selected a cable of 2.5 mil, which is able to take 23 amps. So we're happy, aren't we, that they're correct in the on-site guide in this instance. Happy with that. Perfect. So we've selected 1 mil for our lighting circuit and 2.5 mil for our radial circuit. So we're nearly there. We've selected our cable size. So let's move on to the next step now.